Hello students, good morning. Today I am going to discuss one organic chemistry based question. Whatever the organic chemistry question you are going to deal, just have this basic reaction mechanisms. There is basic idea about the reaction given by the organic compound. I will give you the easy way to find out the basic reaction that has been given by the particular organic compound. For example, in our 11th and 12th standard, we are learning about hydrocarbons, right? In the hydrocarbons, we are having alkane, alkene, alkyne will be there. And then we will have an hydrocarbon, that is aromatic hydrocarbon will be there. Aromatic hydrocarbon, that is the hydrocarbon with the benzene ring. Aromatic hydrocarbon, benzene ring or whatever may be. Aromaticity will be there. Aromatic hydrocarbon. If you are taking aromatic hydrocarbon, there will be a different reaction. If you are taking alkane, there will be only free radical substitution. So not necessary to worry about the all other mechanisms. When you are having alkene, you think about only the free radical mechanism. Free radical mechanism. And then alkene and the alkyne both are having double and triple bond, right? That's why the addition reaction will always be given. And then the next one will be, that is in our 11th standard, we will learn about alkane, alkene, alkyne, aromatic hydrocarbon. I will deal with aromatic hydrocarbon later. The next lesson, haloalkane, haloarenes, right? So alkyl halide, we are going to deal with alkyl halide. Alkyl halide means the halogen which is attached with the alkyl group. The alkyl group may be primary, secondary, tertiary, allyl, benzyl, like that. So when you are having alkyl halide, there will be two kind of mechanism. One will be nucleophilic substitution. So first of all, you write this one in a front page of your book. It will be helpful for learning any organic chemistry question, any organic chemistry reaction. These 7 mechanism only will happen again and again. So not necessary to bother about the so much reactions are there in organic chemistry. How can I memorize all the things like that? Not necessary to memorize all the mechanism, because these mechanisms are going to be repeated in your 11th and 12th standard. So in alkyl halide, there will be nucleophilic substitution. And then there will be beta elimination depending on the reagent. Beta elimination. So depending on the reagent, it will be there. When I'm solving the corresponding question, I will explain in which case there will be nucleophilic substitution, in which case there will be beta elimination. Follow my regular videos. And then alkyl alcohol. Aromatic alcohol, aromatic halide, I will deal later. Alkyl alcohol. Alkyl alcohol will also give the same mechanism like nucleophilic substitution as well as beta elimination. And then we are having aldehyde, right? Aldehyde and ketone. Aldehyde and ketone. So whenever you are having aldehyde and ketone, there will be a carbonyl group, right? The carbonyl group always there will be a del plus del minus charge. Remember that this is the only kind of reaction that will happen in aldehyde and ketone. The reaction is responsible. There is a carbonyl group is responsible for that reaction. That is nucleophilic addition reaction. There is a double bond. Double bond will always give addition reactions. Particularly, this will be nucleophilic addition. My students know about that name, why we are having nucleophilic addition particularly like that. But anyway, if you don't know, just follow my regular videos. And I think here itself we are having carbonyl group addition. So I will give you why we are calling that as why we are calling that is as a nucleophilic addition instead of normal addition. Nucleophilic addition reaction. So what are the things we have seen in alkane, alkene, alkyne hydrocarbon, alkyl halide and aryl halide is also there. Aryl halide I will deal later. Alkyl alcohol is there, aldehyde and ketone is there. And the amine, there will be different kind of reaction, and amine is a separate topic, so not necessary to worry about that. I will deal with amine in a separate topic. And then aromatic halide. I told you that aromatic halide, aromatic aldehyde, aromatic alcohol, all other things, anything, majorly it will give electrophilic substitution. Electrophilic substitution. Electrophilic substitution will be given by any aromatic compound. It may be a hydrocarbon, halide or alcohol. So in our 11th and 12th standard, we are going to deal only with that. So whenever you are dealing the mechanism, you have to check what about the reactant, whether the reactant is particularly halide, particularly the alkane, or that is hydrocarbon, particularly the aldehyde ketone, like that you have to think. And some acceleration and reduction mechanism is also there. Acceleration and reduction also will follow that same kind. But there will be a simple shortcut for that oxidation and reduction reaction. So not necessary to bother about this, bother about that oxidation and reduction. I will teach you when oxidation and reduction happen by the particular reducing agent and oxidizing agent in another one video. Okay. So first of all, we are going to use this one. I will solve the question based on this one. So first one, look at this. This is actually the halide. The halide will give only, there is aromatic halide, electrophilic substitution. So I'm going to check the reagent. Look at this. The reagent is first, they are giving the reagent Mg dry ether. Mg dry ether, magnesium dry ether will not produce any electrophile. If you want to give the electrophilic substitution, then you have to give the corresponding electrophile. For example, if you are giving AlCl3 and Cl2, there will be a Cl plus electrophile. So you will get the electrophilic substitution. That is, any H at the benzene ring will be released. Look at this, each hydrogen here will have, that is each carbon in that benzene ring, except that chlorine attached carbon, all will have a, wait a moment, all will have the hydrogen, right? So here any hydrogen can be released by the electrophilic substitution, but chlorine is a ortho para directing. Because of that lone pair, there will be a minus charge accumulation at the ortho and para position. So chlorine is a plus R group. That's why plus R group will give always the electrophilic substitution, allows the electrophilic substitution at ortho and para position. So para position product will be the major one. But here we are not at all giving that electrophile. AlCl3, Cl2 will produce electrophile, or concentrate HNO3, concentrate H2SO4 will produce electrophile. But here Mg dry ether is a Grignard reagent. Grignard reagent is having a special reactivity, that is actually the inorganic reaction. So inorganic and organic combination will give, that is a metallic compound, organometallic compound will be produced. So there will be a special mechanism, and don't think like that, ma'am, you are saying that only 7 kind of reactions are there, but you are giving more than that. Like that you may think. Grignard reagent, some special cases will be there. Grignard reagent always behave in the same manner. So not necessary to bother about that, the special mechanism. You will give a regular practice on that particular mechanism itself, you will automatically learn that one also. So dry ether only you should give. It should be very important. If you have given some other organic solvent, some other inorganic solvent, that is a water, polar solvent, it will give some other reaction. So magnesium chlorobenzene, in the presence of magnesium, this is not actually the organic mechanism alone. This is an organic organometallic compound. That's why we can't able to categorize that into special category among that 7 kind of reaction. And then just to insert that magnesium, it's very easy. Just to insert that magnesium between carbon and halogen bond. Just to insert that magnesium between carbon and halogen bond. And the second part, they are adding carbon dioxide. So carbon dioxide is having carbonyl group. I already told you, if there is a carbonyl group in carbon dioxide as well as aldehyde as well as ketone, here if you are using carbon dioxide, just split into plus and minus. Del plus and del minus will be there, and always Grignard reagent will be splitted into plus part and minus part. Why the carbon becomes minus part? When you are comparing carbon and magnesium will be the electropositive, carbon will be the electronegative. So just to add that, break this bond. I told you already, nucleophilic addition will happen at that carbonyl compound, that is carbonyl carbon. Nucleophilic addition. Just what is the meaning for addition? Just we have to add the add the 2 species instead of the double bond center. So look at this. I am going to just one double bond I am keeping as such, and another double bond I am going to break it, and I am going to add 2 species here. This is called addition. But in the carbon part, nucleophile is going to be added. Nucleophile is nothing but the species which is having negative charge attracted by the nucleus, attracted by positive charge. So positive charge is nothing but the nucleus. That's why we are saying that name, nucleophile. So nucleophile you are going to add here MgBr. That is nucleophile you are going to add at carbon. That's why we are giving the name nucleophilic addition. Normally in double bond center, here look at this, in this case, if you are adding 2 reagents, for example plus part and minus part, if you are adding some plus part, If you are adding some minus part after breaking that bond, then here carbon is having the addition with that carbon to here electrophile is added at the carbon atom, nucleophile is also added with the carbon atom. That's why we could not categorize that into that addition into electrophilic addition or nucleophilic addition. But here particularly the carbon will attack the nucleophilic part. We are dealing only about the carbon in our organic chemistry. That's why we are giving the special name nucleophilic addition. Nucleophilic addition reaction will be there. And then here I have added the positive part with the carbon and the negative part with another one, oxygen. So oxygen will have MgCl part. That MgCl will be there. And look at this, when you are having this one, when you are having C double bond O, here look at this, this is also double bonded compound, so we could not break it it down. This is not a weak group, and benzene ring is also not a weak group. Then how the reaction will happen? Then there will be only hydrolysis. So they have given that hydrolysis. Look at this, in this reaction itself, first step they are adding magnesium triether to prepare the Grignard reagent and CO2 and hydrolysis in the presence of acid. The hydrolysis mechanism will be faster when you are adding acid catalyst. So just to break it and just to break this one, this is here we should break at this point. Just break here and then add H here and then add OH here. So finally you will get the byproduct MgOH and Cl, and the other product same benzene ring and C double bond O, here OH will be there. Benzoic acid you will get, right? And then they are adding ammonia. Actually for carbon and carboxylic acid I didn't give that reaction mechanism. I will give the reaction mechanism. It will be very easy. Carboxylic acid, C double bond OH. When you are having carboxylic acid, here also nucleophilic addition, and then because carbonyl group is there means definitely nucleophilic addition will be there. Because of that acidic group, that is because of this active group also present in that carbonyl group. That's why we are having nucleophilic addition elimination mechanism. As I told, nucleophilic addition only will happen with the carbonyl carbon, but here OH, some active group is there with the carbonyl carbon. That's why nucleophilic addition elimination will be there. Nucleophilic addition elimination mechanism will also be there. Nucleophilic addition elimination. So here they are going to add ammonia in the third step, and then look at this. Just if you are adding that one, nitrogen is having lone pair of electron, C double bond O will be converted into C single bond O, that is the del minus will be added at this position. So NH3 and OH will be there. Here the double bond will be converted, not necessary to know about the mechanism, just H2O will be removed. C double bond O, NH2 will be there. Because of that is I told you there will be addition elimination mechanism. So NH2 added, H2O eliminated, that's it. And then after that they are adding bromine and NaOH. Bromine and NaOH. I already told you in the amine part we are having some special mechanism, special rearrangement will be there. So here bromine and NaOH will be the Hofmann bromamide mechanism, Hofmann bromamide reaction, Hofmann bromamide, or otherwise we can call that as a Hofmann degradation reaction, degradation. So when you are having degradation means just remove that carbon dioxide. So after removing that carbon dioxide, automatically that NH2 will come there. There is a rearrangement reaction. Hofmann bromamide is a Hofmann rearrangement reaction. Huge mechanism will be there. Not necessary to know about that one for NEET and JEE part. Just you can write the product, but they will ask mainly about the intermediate in that Hofmann bromamide reaction. So intermediate you should give. After the rearrangement, there will be an intermediate. That intermediate will be, that is the intermediate. There is the rearrangement I told you. So N will be there with the benzene ring. Double bond C, double bond O will be there. And then that intermediate will be converted into product. Carbon dioxide will be the byproduct. Hope you know about that question. I will explain that same question in Tamil also. Okay. Thank you, students.